Every year, millions of tons of plastic enter our environment, and they don't just disappear. Over time, these materials fragment into smaller and smaller pieces known as micro and nanoplastics. These particles are now found everywhere, in the oceans, in the food we eat, and even in the air we breathe. They are truly unavoidable. The challenge is that these particles can get so small we can barely detect them, making it harder to know how big the problem is. Because while there are analytical techniques for large, visible plastics, we lack methods for identifying and measuring particles below a few micrometers. That's where my research comes in and where pyrolysis-gas chromatography-mass spectrometry becomes a powerful ally. A complicated name for a rather straightforward principle. And it works like this. For instance, we pump air through a filter that traps the micro and nanoplastics. Then we put the filter or a small portion of it into our instrument. There, the plastics present on the filter are broken down into smaller fragments. These fragments are then separated and detected. Because each type of plastic falls apart into different fragments, we can use that unique fragmentation fingerprint to identify which plastics are present, and we can determine how much of each plastic type is in a sample. Even particles in the super small nanometer range can be detected. By improving our analysis of these tiny particles, we will be able to understand the full extent of plastic pollution. Because the better we measure, the better we can protect our environment.